What we're going to work on next, okay, is that problem set. But before we do, let's look at our study so far of volume, and let's read together our objective here. On the count of 3, 1, 2, 3.
I can find the volume of a rectangular prism by using one of the two formulas and the standard algorithm of multiplication.
Okay, good. There's a little bit more information on our objective board that we might use today during our lesson. Okay, what are the two formulas? It said I can use one of two formulas. What are they? Okay. Wyatt.
Length times width times height and base times height.
Okay. Can anybody explain the difference between those two formulas? Toby?
So length times width times height is where you times all three, you multiply all three dimensions. But base equals length and width, so it's like shorter.
Okay. So did anybody want to elaborate on that second one? Base times height or face times height? Okay. She got it right. She said the base includes the length times width. Yeah. Alexis?
Volume is base times height, which you can also say is area times the height equal to volume.
Perfect. Okay, good. And then another thing, we have different types of measurements. So today we're dealing with centimeters and milliliters. Okay, can anybody tell me the relationship between those two? Or when I would use milliliters and when I would use centimeters? Max? 1 centimeter cubed equals 1 millimeter, right? And when do I use millimeters over centimeters? When do I use millimeters over centimeters? Jackson?
When you're using liquid and you're pouring liquid into something.
So which one do you use then?
Milliliters for the liquid.
Okay. And what type of a measurement is centimeters? What type of a measurement is centimeters, Ben?
Like you can measure like length or width or something.
Length, okay? It's a linear measurement. Okay, perfect. All right, let's look at one problem here. I'll put it up here for you guys. Okay, let's look at this figure right here. Let's look at this figure right here. It says, okay, that I have a container, okay, and its dimensions are 40 centimeters by 30 centimeters by 20 centimeters, okay? It says that I'm going to fill it with water, okay? Turn and talk to your partner about how you would solve that and which measurement you're going to use or what unit you're going to use. Talk to your partner about how you would figure out. Okay. Who can tell me which of the formulas I'm going to use here? Which of the formulas I'm going to use according to the information that they gave me? Gavin? Two formulas. They're both up here. Okay, you're going to use centimeters for your units. Okay, that's the units that they gave you. But since it's water, okay, at the end I'm going to convert it to millimeters. Okay, and then which formula, Ethan, would I use? Okay, what's the base of this?
30 centimeters times 20 centimeters.
Okay, and what's that going to equal? Can you do that in your head? $30 times 20, that's the base, is the length and the width, correct? Okay, so 30 times 20, let's do it together. 0 times 0? 0. Okay, 0 times 3? 0. 2 times 0? 0. Okay, and 2 times 3? 6. Okay, 6. Okay, and so when I add 0 to 0? 0. And 0 plus 0? 0. 6 plus 0? 6. 600 what?
Centimeters cubed.
Okay, and then we just figured out that that's the base of this. Centimeters squared, thank you, because we only multiplied the base times or the length times the width. Okay, the base equals, thank you, Kira, because how many things did we multiply? 2. And so that gives us our exponent there on our units, okay? What's next? What's next? Marcos?
You multiply by 40.
Multiply that by 40. Okay? 40 what?
Centimeters.
Okay, and 0 times all of it?
0.
Okay, and 4 times 0?
0.
And 4 times 0?
0.
4 times 6?
24.
Okay, so when I add that up, 0 plus 0?
0.
0 plus 0?
0.
0 plus 0?
0.
4 and 0?
4.
And 2 and 0?
2.
Okay, so what number is that? 24,000 what?
Centimeters cubed.
Okay, centimeters cubed, all right? Now, if I'm going to pour water into there, what will the units become? What units would I give now if I'm going to pour water into that container? If I'm going to pour water into that container. Daniel? Perfect. All right, so go ahead and work with your partner, okay, on the problem set. I'll give you guys about 5 minutes. My group of people come up with me and we'll look at it together. Okay? Josiah's not here, but I need Maria, Fernanda, and Ryder. Okay? And let's take a look at it together. You guys should be communicating with your partners, okay, and discussing what's going on. All right, let's have a look at it. Okay, the problem set. You brought your problem set? Okay, the problem set is this one right here. Okay, this one right here. Okay, so, if I want to find the volume of this, it says the tank is shaped like a rectangular prism. It's filled to the top with water. Okay, how do I find out how much that is? Okay, let's start with that. Okay, start with the length times the width times the height. Yeah, you can do it on there if you want. Separate or on there. All right, let's see what our other friends get.
Centimeters squared.
Okay. Okay, so you multiplied together. Tell me what the dimensions are. $10? Okay, so 8 times 10 is 80 times the 13. Okay, 0, 0, 4, 24, 1 times. Okay, so now it's asking me, where is that going to come on my little graduated cylinder? Fill out where that's going to come on my graduated cylinder. You guys communicating with each other? Okay. Do you get the first one?
Yeah.
Okay. Are you doing it on a separate sheet of paper? Good. Okay, perfect. Okay. Okay, what's your strategy?
More. Well, we're just finding the volume, and then we're doing it here and seeing if it can hold like the same.
See whether it fits in there or not. Okay, good. Which strategy are you guys using for the first one?
We were using like multiplication for 5. Wait, you talking about number 4?
Yeah.
Oh, we're
So what's the relationship between the two of them?
They're the same.
Okay, that's the right answer. Good. Okay. So did you guys determine? What's that? It overflows. It overflows. Why?
because you have 40 extra milliliters.
40 extra milliliters. Okay. So how many milliliters would be exactly fitting in there?
1,000.
Okay. What does that equal?
1 liter.
1,000 milliliters equals a liter, and I have 1,040 centimeters cubed. Okay, that's going to be 1,040 milliliters, which is too much, correct? Okay. Keep going. All right, you guys go back. Okay, let's take a look at the first one. Let's take a look at the first one on there, have a little discussion about strategies and what we learned from it. What we learned from that. Okay, so the first one, problem looks like this, okay? Who wants to read? Right there where it says number 5. Max? Everybody's following along? Okay, it's filled to the top with water. Okay. The next thing says, will the beaker hold all the water in the tank? Talk to your partner about how you determine that. Talk to your partner about how you determine. Okay, who wants to share out from their group? Okay, Marcos, how would you go about finding out if the water in here is going to fit if I pour it into there?
What we did first was length and width and height, and we got 1,040
1,040 what?
milliliters cubed.
Well, how did you get milliliters if you multiplied? Okay, so you got centimeters, but then when you poured it in, it comes to milliliters. Okay, good, Marcos. Okay, who can tell me, would you say you got 1,040? Did anybody else get that? Okay, so it seems like that's probably right. If I multiply 80 times 13, it must be 1,040. And let me ask you this. Okay, when we dump it in there, the scale is in milliliters. And how many milliliters is half?
500.
Okay, so how many milliliters is full?
1,000.
Okay, so, and what larger unit is 1,000 milliliters?
1 liter.
Okay, good. Is it going to fit? Raise your hand. Is it going to fit? Is it going to fit? Veronica? 1,040 into one. So you want to change your answer? Okay, will it fit? Why not? It's more than the beaker can hold by how much? Noah? 40 milliliters. Okay, so did we explained our answer. We said it won't go in there. Make sure we answered all the questions. All right, let's look at, did people get to the next one?
Yes.
Okay, I'll give you guys a couple more minutes. My group, come back to me. Okay? All right. So this one.